Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by Gauteng Department of Education in collaboration with the Sabono Discovery Center and the broadcast by Pagama Research and Development. Please send us questions on WhatsApp number 079 578 2908 079 578 2908. Please do not send voice notes. Please send your picture of your answers and also ask questions on that WhatsApp number. Today's topic is the application of calculus, which is paper 1. I know you've done calculus in term 1, but remember in calculus we have the application which you do. I think you've done it almost at the end. So let's go through this section and then so that we are able to can answer it in our test and in our exams. Today's lesson objective is by the end of this lesson, you must be able to optimize the measurements of 2D and 3D dimensional shapes. So in other words, we're going to do the maxima and the minima. Remember when you're doing cubic functions, you also did the maxima and the minima. So we're going to now deal with 2D and 3D shapes. Number 2, you need to be able to solve practical problems, concerning rates of change, and including the calculus of motion. So at the end of the day, you must be able to can do the two. Right. What it means, what does it mean to optimize? Now here, the drawing and the interpretation of those cubic functions, it's one application. So remember you did the drawings of those cubic functions. It's one of the application of calculus. So we are applying calculus rules there. Optimization is another application of calculus. So in other words, we are applying calculus, but we are optimizing in this. So the word optimization is just another word of, how do we apply calculus rules there. Now the process of finding the maxima, this is what we are going to be talking about most of the time, or the minimum values is called optimization. So when we optimize, we try to do things like maximizing the profit in a company, minimizing the costs, or finding the least amount of material to make a particular object. And you'll see in the examples that we are having that we are going to be talking to this. These are very important in the world of industry. Remember, we are applying now what we have learned in calculus. We are applying your rules of calculus. You're applying your principles that we have done in calculus. But let's quickly go to the pre-knowledge activity before we do the real practical application of this of calculus. I've put in here the sketch, the function here of f of x, it's equals to x cubed minus 6x squared plus 9x minus 4. Now I want you to draw this sketch. So I'm going to be drawing it with you. So take the sketch down and you do it with me. Now, the first thing that we're going to do when we're drawing the sketches is to find the x and the y intercept. See, this is the first thing that we need to do to get the y and the x intercepts of the graph. You still remember, to get the x-intercept, we need to put y0. To get the y-intercept, we need to put x0. So in this case here, the easy one to do will be the y-intercept. Love the y-intercept. It's only one mark there for y-intercept. So I'm going to say, now to get my y-intercept, I'm going to get f of 0. So for that, so to get f of 0 there, so I'm going to get y-intercept. So if I put x0 there, put x0 there, put x0, the only value that is left will be minus 4. So the f of 0 is going to be negative 4. So I hope you get that one right. So therefore, the y-intercept of that graph, it's going to be -4. In other words, when I go to my Cartesian plane, the y-intercept will be -4. You'll see when we go to the the Cartesian plane, we'll have to check what the y-intercept is. Now, the x-intercept is the one that is a bit of a challenge, but I know you have done this graph previously. Now, I hope you all understand how to do that. Now, how do I get the x-intercept of the graph? I put y0. Remember, f at x is nothing else but y. So I'm going to put y, f of x to be equals to 0 and try to solve that. But trying to solve that will be a bit of a challenge. Now, first of all, remember we've got 3 or 4 methods that you can be able to use there. But for now, I'm going to shoot to the easier method to do that. So remember, I need to first find a factor. So I substitute by 1, substitute by -1, -2, by 2, until I get a 0. So with this one, I figured it out that it will be x minus 1 as a factor. So if I say x minus 1 is a factor, so if I substitute the value of x by 1, I'm going to get a 1 there, I'm going to get a -6, I'm going to get there a +9, I'm going to get there a -4. And if I take those ones down, 1 plus 9 is 10, -6 -4, it's -10, 10 minus 10 is 0. Yes, I've got the factors right. So x minus 1 is a factor, but you know you have to go through that or use any other method. Now, the shorter method will be, for me, it will be this one, because remember this is equals to 0. I need the x-intercept of the graph. So the shorter method for me will be, how do I get the x cubed here? So for this, I'm going to multiply by x squared. How do I then get my -4? Then I'm going to multiply this one by +4. Okay, so now, so how do I then get the middle term? So I'm going to say, if I've got -1 times x squared, that will give me -1x squared. But to get to -6, remember I'm talking about x squared. To get to -6, from -1 to -6, I must add -5. So in other words, here in the middle, I'll get -5. So you can use any other method that you are comfortable with. So from this, then I can have x minus 1. Can factorize this. This is easier to factorize. So to factorize that will be x and x. I'll have 4 and 1. The signs are going to be both negative. So I'm going to have my x equals to 1 or x is equals to 4. And again, x will be equals to 1 for that one. So now I'll have x equals to 1 and x equals to 4, because that one is repeating itself. So my x-intercepts are going to be x is 1, x is 4. So I've got the x-intercept, I've got the y-intercept. Now, finding the coordinates of the turning point of the graph. So remember, the function that we have there, we also need to find the coordinates of the turning point of that graph. How do I find the turning points of the graph? Remember, we are going to do the derivative. So what we're looking here is nothing else but the maxima and the minima of the graph. Now, how do I get that? Now, I need to find f prime of x. So in other words, remember, why do we say it's f prime of x? Because the gradient at the turning point is 0. We are going to equate that one to 0, so we derive it. So when we derive that, we get 3x squared minus 12x plus 9. So remember the function that we had there. If I derive, I'll have 3x squared minus 12x plus 9. Then minus 4, we get a 0. So from there, I'm going to take this one and equate it to 0. So it's 3x squared minus 12x plus 9 equated to 0. You must always know why we are equating it to 0. It is because the gradient at the turning point is 0. So if I've got the gradient at the turning point maximum, the gradient will be 0. If I have a minimum there, the gradient will also be 0 there, because it's a line which is horizontal, the horizontal line which is parallel to the x-axis. Right. Now, in this one, then I can divide throughout by 3. So I'll get x squared. I just want to quickly simplify that. Then plus 3 equals to 0. Then I factorize this. Then I'm going to get x minus a3 and x minus a1. Okay, and then the x values, they are going to be x equals to 3 or x equals to 1. But I'm not done. What do I need? I need coordinates. So the word coordinate means that I must have that bracket like that with an x value and a y value. So those are coordinates. So now I need the y values. So I've got the x values, I need the y values. How do I get the y values? I substitute the x value into the original equation. But if I take the 3 and substitute it into the original equation, that's where I'm going to get a coordinate of x and y. So how do I get that? So if I substitute that one, I'm going to get a -4. So if you take your calculators and punch in 3 into the original equation, the value of y will be -4. If I take a calculator again and punch in 1 in the place of x in the original equation, the answer that I'm going to get there will be 0. So meaning that I've got two turning points. So I've got turning point 1 and I've got turning point 2 there. So I've got two turning points. So I've got that one will be 3 and -4. The other one will be 1 and 0. So now I've got coordinates of the turning points. See, so sometimes we'll have one point, one turning point there, but in this case we've got two of them. So we'll check which one is the maximum, which one is the minimum, so that then we are able to, when we draw the sketch, then we'll see which one will be the minimum, which one will be the maximum. All right, so now we've got those two turning points. Now the next part here is to draw the sketch. Now, how do I draw the sketch? So to draw that sketch, I need all the points. Remember, I said the y-intercept of the graph was -4. Okay, I put a point there. And we said the x-intercept of that graph was 1 and 4. So there's an x-intercept there at 1 and at 4. Okay. Now, the biggest thing on how to draw this sketch here is to do this. Now, we have seen that our a value there will be greater than 0. In other words, our a is positive. So in parabola graph, we talk about the smiling graph. Now, in this one, then you'll see what we talk about here. So when the a is greater than 0, and these are some of the notes that you must just put in your book, just there. A greater than 0, then what do we have as our graph? Then the graph will have a cap, a cap and a cap. So in other words, a greater than 0, we start, the first turning point will be a cap, the next turning point will be a cap. Now, if a is less than 0, therefore, the first turning point will be a cap and a cap. The next one will be a cap. So if you know those, then you will be able to draw any graph. Because I know when you have points, you just put the points and you don't know where to start and where to go. So the first turning point is 1 and 0. So here's the first turning point, which is 1 and 0. The second turning point that we have there was 3 and -4. So that will be 3 and -4. So now we have the two turning points. The first turning point, we said when a is greater than 0, it's a cap. So I'm going to draw a sort of a cap on that one. So I'm drawing a cap. Okay, on the second one, I'm going to draw a cap. So here on the second one, I'm going to draw a cap. So I've got a cap and a cap. So now, for that one, it's a cap and a cap. For this one, it's a cap and a cap. Right, so now let's draw. So I've already drawn my cap here, so I'll just continue with that line there. I've drawn my cap there, I just join that. Then I'm going to join that. There's no way that you are not going to be able to draw this sketch. So now I know this part, this turning point here is the minimum, and that part there here is the maximum. So I've got the maximum point and the minimum point. So this is what we're going to be dealing with in the next slide now. Okay, now we've drawn our sketch. Nice. So now the next one, let's look at the formula that we're going to use in this optimization. The perimeter and the area of a rectangle. So I've put that, it's an easy one. We have done this in grade 8 and grade 9. How do I do the perimeter? How do I write down the perimeter of that? So the perimeter of a rectangle, remember a rectangle, I'll try to draw a rectangle, right? That is a rectangle where this side here is equal to that side, this side there will be equal to that side. Okay, and all these angles are 90 degrees. Now, what is the perimeter? Perimeter is the is the length from here to there to there to there, and then we add all those lengths, we get a perimeter. Okay, in simple terms. The area is the surface that is occupied here. That is the area. So the area is the surface that is occupied, and the perimeter is the surrounding. So in other words, it's that part, that part there. So if I take the length of all those sides, I'm going to get the perimeter of the rectangle. But the surface here will be the area. Now, the formula for perimeter will be 2 multiplied by length plus 2 multiplied by breadth, which will be the same as taking out 2 as a common factor. Then I'll have length plus breadth inside. So I take the length and the breadth, then I can take that one, and then from there I can add them together and then multiply them by 2, because they've got 2 of those, 2 of those. Now the area will be the length multiplied by the breadth. In other words, I take the length, I multiply by the breadth, I get the area of a rectangle. We are going to be using some of this formula in there. In the first activity that we're going to be doing, we're exactly going to use what we talked about now. So if you look at that question, now that question states that a farmer needs to fence a rectangular field using 100 meters of fencing. In other words, what is given there? It will be 100 meters of fencing, which is going to be our perimeter. In other words, this guy wants to fence the whole area, but he's got 100 meters of that. So he's got 100 meters of that fence. So he wants to fence that whole area. Now, but he wants to make a rectangle that will enclose the greatest area. Right. Now, what do we need? We need to know what is that length here. It's x. We need to know what is that length here. We don't know. It's a width. So I'm just going to call it width. So it's a width. I don't know what it is, but that one I know it's x. But I know if I add all those things, I'm going to get 100. So now, the first question says, write an expression for the area of the rectangle if the length is x. So in other words, I've got 3 marks to do there. So let's see how we're going to do that question. Now we know that our length is going to be equals to x. Right, so now it means if I need perimeter, my perimeter is going to be equals to, remember it is 2 into the length plus the width or the breadth. Right, so now I'm given what? The perimeter. So the perimeter is going to be 100. I've got a 2, I've got a length which is x, but I need the width. I don't know what the width is. So I need to first write the width in terms of x, because I don't want any other thing there. So here, I've got 2 variables there, I just need 1 there. So what should I do there? Then I'm going to divide both sides by 2, which will give me 50 equals to 2, which is equals to, inside the bracket there, width plus the x plus the width. So now I need the width now. So my width is going to be 50 minus x. So it means that this part here is going to be 50 minus x. So I have that. So my width is 50 minus x. I know what is my length is x here. So they say write the expression of the area of the rectangle if that one is x. So in other words, I just need everything to be x. So how am I going to get the area? Now the area, remember area is length multiplied by the width. So what is my length there? My length is x. My width is going to be 50 minus x. Then I just multiply in, I'll get 50x minus x squared. So that is the area. Now we're going to mark this one. Now here, 3 marks. 3 marks, yes, 3 marks, yes. So how do I do that? So my first mark there, I'll get a mark for the substitution. Mark for the substitution. Most of the time we find in the area, it's the formula I given. Mark for the substitution. I'm going to get mark for this, and obviously the area. My last mark will be for the area. I mean, the length multiplied by breadth is something that we have done in grade 8, grade 9, and grade 10 also. So we have done that. We know how to multiply those two. Okay, now, the next question says, what are the dimensions of the rectangle that will result in the greatest area? Remember, once we see the word maximize, minimize, greatest area, and all that, we know there's something that we need to do there. So what are we going to be doing? The way that is going to guide us to do that, it is that greatest area that guides us to differentiate. So I'll have A is equals to 50x minus 2x squared. So what should I do there? I want to find the dimensions. I don't know what the dimensions are. I don't need this x. I don't need this 50 minus x. I need the dimensions. So now, what should I do? I'm going to then differentiate. I need the greatest area, so I need to differentiate. So how do I differentiate? I'll say the A over the x. And remember, when I talk about the greatest area, I'm going to equate that to 0. So here I'm going to say, because I need the dimensions, remember, I need the value of x so that I can substitute it into my figure there. So there I'm going to have 50 minus 2 times 2 is 4. So we have x. Right. So now I've now differentiated this one. Now I need to find the dimensions. Check. So therefore, I need to find the dimensions of that. So it's 50 minus 2x. So now how am I going to get the dimensions there? So I'm then going to say, okay, so here it's going to be 50 minus 4x. It's equals to 0. So 50 minus 4x equals to 0 because when I differentiate it, I said 2 times 2, and that will be 4, and then we have a 1 there. Okay, so now I'm going to have minus 4x. It's equals to 50, negative 50. So which gives me x, it's equals to. So if I take the 50 and then I divided it by 4, then I've got 12.5. So I'll have 12.5 here. Right. So now I've differentiated that. So it's 50 minus x. It's 50x minus 2x squared. Differentiated, we get that, and then we get that x. So how am I going to get the dimensions of that? So it means that my length there is going to be 12.5 in centimeters. Then I'm going to get my width there will be 50 minus 12.5. So which is going to give me 50 minus 12.5, and that will give me 37.5. 37.5. So that is what I'm going to get as my, okay. Now, so the area we got, then from there we differentiated because we talked about the greatest area there, and then from there we get our answer to be that. All right, now, more formula. You need to find the formula below when you want to optimize measurements of three-dimensional objects. So in other words, we have a rectangular prism now. Now we no longer have a rectangle, we have a rectangular prism. Okay, so meaning that there's a 3D shape. Okay, we've got the length, we've got the width, we've got the height. So where L is the length, the width, and the height. Now we talk about surface area. We no longer talk about the area. We talk because we've got surfaces there, so we have to add all the total surface area of that. So meaning that we're going to have the length here, we have another length here. So we're going to talk about 2 of the length multiplied by the width. We have the width there, we've got another width on the other side. So we're going to talk about 2 width height and then 2 length height. So that's the formula that we're going to be using for the surface area of a rectangular prism. For the cylinder, we have the radius, which is half a diameter. R, we have got the height. So for the surface area, why do we need to have that? Remember that the surface area here, this is the surface area of this cylinder. The volume for the rectangular prism will be length times width times height. The volume of that will be pi r squared, which is nothing else, but if you need the volume, you need the area of the base. So the area of the base is pi r squared multiplied by the height. So the area of the base multiplied by the height. Most of the time you find that this formula are given to you. Then you are just going to apply your knowledge there. Now, here's an activity which I want to do with you. Now here it says the edges of a rectangular box. Now you see the rectangular box. So there's 3D shape. It's x, we have x, we have 2x, and we have 180 minus 3x. For 2 marks, we need to find the volume of the box in terms of x. So now, if you quickly go back there, what is the volume of a rectangular box? A rectangular prism will be length times width times height. So we go there and check our length times width times height. So I'm going to have the volume is going to be length times width times height. We just substitute. What is our length there? It's 2x. What is our width? It's 180 minus 3x. What is our height? It's x. Then we just multiply. So it's 2x multiplied by x will give us 2x squared. 2x squared multiplied by 180 will give us 360x squared. And 2x squared multiplied by negative 3x will then give us negative 6x cubed. So we're going to have that. So it's 360 x squared minus that. So this is the volume in terms of x. So that's what we're going to have. So A is done. So it's just going to be substitution and the answer, and that will give you your leg of 2 marks. Okay. Right. Now, we continue with activity 2. It says determine the value of x. See now, we should make the volume a maximum. So the guiding word there will be the maximum. Remember on your graph, when we needed the maximum, we differentiated to get the turning point. Here we need the maximum, the value of x, which will make the maximum. In other words, if we connect it to my graph there, it simply means we need the x value of the turning point. Okay, so we need the x value of the turning point. We have the function is given. So the function we already have. So our function there is v equals to 360x squared minus 6x cubed. So now I need to find the maximum. So what do? I derive. So for derivation, I can write it like that. Okay. Then from there, I'll have 2 multiplied by that. I'm going to have 720x minus 18x squared. But then I need a value of x. Remember the maximum, the gradient, then the gradient on the graph will be equals to 0 when we derive. So here when we derive again, we still put that one to be equals to 0. So we say 720x minus 18x squared equals to 0. Then I take out the common factor. You can see there we are having a common factor, which is going to be 18. So I can have 18 as a common factor. And I think inside there, I'm going to have 40. Then I'm going to have minus the x equals to 0. Because 18 multiplied by 40, it's 720. How do I do that? I just divide 720 by 18, you get a 40, and then we get, inside the bracket, we get 40 minus x. The first x value will be equals to 0. 40 minus x, 40 is equals to x. So meaning that x there will be equals to 0, and the other 40 will be equals to, the other x will be equals to 40. But if I take a value x equals to 0, and substitute it there in my original, I'm going to get 0, which really will not make sense that I haven't maximized it. So it's at 0. Okay, the volume is 0 there. Can you imagine? The volume, I have a box and I've got something inside and I say the volume will be 0. It will not make sense. So it means that I'm going to discard that answer there, and my answer will be x is equals to 40. So I get the value of x, which is going to be 40. So I put 40 on my value of x, then I get a maximized volume. Right. C says I must get the dimensions of the box. Easy. How do I get the dimensions of the box? The first one, we know x is 40. So the first one, which is our height, it's 40. Our length, we are substituting the value of x there by 40, which is going to be 80. 2 times 40, it's 80. Then we have our width. We're substituting the value of x there by 40. So it's 180 minus 3 times 40, and that will give us 60. Because it will be 180 minus 4 times 30, 3 times 40, which is 120. So that will be 60. So my dimensions, so there's 2 marks for this. I know the 2 marks will go for substituting this one and that one, because the h, which is 40, you're just giving it to us. We know the x is 40, you're just giving it to us. And with the length and the width, you need some work to do there. All right. Now, the next activity there, activity 3, I'm going to give it to you. Let's take 3 minutes to do this activity. 3 minutes to do this activity. Just look at the activity, and then from there you start doing it. Okay, don't copy the whole thing. Thank you. Okay, I hope you're done. I don't think it was a very difficult question after doing the previous one. And look at the question there. It's a rectangular fish tank, so we're still busy with the rectangular prisms. The length is given, the breadth is given, the height is given, all in meters. Determine the formula for the volume of the tank in terms of x. So we're going to go back to the formula, and we know our formula is going to be our length multiplied by our breadth, in this case, multiplied by the height. So I've got all those. So I substitute. Our length there is going to be 3x. Then we multiplying this one with our breadth, which is going to be 1,5. I'm multiplying with our height, which is 1 minus x. Okay, I'm multiplying. So therefore, if I multiply all this, I'm going to get 4,5 for this one. X multiplied by 1 minus x. So then I multiply the 4,5x into the bracket. Then I'm going to get 4,5x minus 4,5x squared. So for 2 marks there, it will be the substitution and also the final answer. Okay, so if some of the examiners might be very generous and give you 3 marks for that one, but I just think it's just substitution and then just multiply out and then you get your final answer. So the answer there is 4,5x minus 4,5x squared. Hope you got this one right. Okay, the next one, yeah, I love this word, maximize. When I see that word in calculus, I just know, I need to differentiate. So hence, determine the value of x. See, when they say hence, it means that use what you got previously. So what did we get previously? We got volume equals to 4,5 x minus 4,5 x squared. So that's what I got. So now they want us to maximize the volume of the tank. So in other words, I'm going to have dv over dx, and I'm going to equate that one to 0. So I'm going to have 4,5 minus 2 times 4,5, then that will give me a 9, and that's an x. So from there, I'm going to equate that to 0, 4,5 minus 9x, it's equals to 0. Remember, when we differentiate, we're actually getting the maximum of that. We must differentiate and we must equate it to 0. So now I'm going to get my x, negative 9x, it's equals to negative 4,5, and the x, it's equals to 0,5. Okay, so if I divide 9 by that, then I'm going to get that. And remember, this is in meters because it was given in meters. So the x value will be 0,5. Okay. Right. Now, another question on that, but now this one it's different. We've been dealing with volume for the past 2 questions, but now we're dealing with the surface area. Now the surface area is now given. Now we need to find the height. The length is also not given, but we are having an expression that is being given there. It says, now the manufacturer has designed a closed box of which the base side has the width of x. So now I've got the width here of x. Nice. The length of the box, it's twice the width. So in other words, if my width is x, what will be my length? It will be twice the width. So it will be 2x. Now I've got 2 sides that I know. I need the third one, of which this is the question. But now what is given? I'm given the surface area. So which means I need to have a formula for the surface area to be able to can get the height of the box in terms of x. Nice. So now I've got the surface area. It is given, it's 120. Good. I'm using this formula here. So now 2 multiplied by the length multiplied by the width. But what do I know? I know the length, I know the width. So I'm going to write 2 multiplied by the length multiplied by the width. So this part is done. The next one here will be plus 2 multiplied by this. What is the width? The width is x. Do I know what is my height? No, this is what I need. So I'm going to write h. Now I'm going to say plus 2 multiplied by. Do you know what? Do I know what is my length? Yes, it's 2x. Do you know what is my height? No, I don't. So I'm going to put h. So if I look at this, I'm going to have 120. I'm going to have 2 times 2, it's 4. X times x is x squared, so it's 4x squared. Now there, if I'm going to get 2xh, I'm going to get here 4xh. Oh, nice. Now I can see I have like terms. You see the like terms there? 2xh and 4xh. So I'm going to have that as 4x squared plus 6xh equals to 120. But remember, what do I need? I need the height. So the height is h. So I must make h the subject of the formula. So I'm now going to have 120 minus 4x squared. This side I'm going to add 6xh. So I'm going to make h the subject of the formula. Then I'm going to divide everything there by 6x. So I'm going to have 120 divided by 6x minus 4x squared divided by 6x. So therefore, I'm now going to have my h as 20 over x, because 6 into 120 goes 20 times, minus 4 over 6 will give me 2 over 3, and the x there, because the one of the x will cancel out. So meaning that my height now is no longer h, it is now 20 over x minus 2 over 3x. That is my height. So I've written height in terms of x. In other words, I've got a height, and on the other side, I've got x. So that is in terms of x. That's what it means. Right. Show that the volume of the box will be given as. I hate it when they give me the answer. Because I don't want that answer there. I want to do it on my own and get the answer. Because when they've given me the answer, it gives me a lot of challenges. If I don't get the answer, then I have to try. But now it's nice because then you have to go back and check where your mistakes are. Okay, but for me, I don't want to be given answers. But now let's try this. If I've got a volume of the box, that should be given as V equals to 40x minus 4 over 3x cubed. I know the formula for the volume, no problem. Length times width times height. The length I already know, it's 2x. Remember, it's twice the width. The height, I've got the height as 20 over x minus 2 over 3x. So I'm going to use that because I want the volume to not have an h. It must have x only. Right. What is the length of that? So the length is 2x. What is my width? The width is x. What is my height? Oh, it's that monster here. Oh, okay. But let me write it. It's 2 over 3x. Right. Multiplying now. Okay, so how do I multiply that now? Simplify this. I'm going to get 2x squared here. I'm still going to have my 20 over x minus 2 over 3x. Must multiply out the brackets now. Okay, I don't remove the brackets, I multiply out the brackets. Okay, right. So now I'll have 2x squared multiplied by 20 over x. Oh, I can see my 40 is coming now. So 2 times 20 is 40. Okay, I can just write it down here. I've got 40. Then the x here will cancel with one of the x there. So I'm going to have 1x. Oh, nice. So I've got that part. Nice. Now I need the next part. So the next part there, I've got a minus. Now I can see 2 times 2. Remember, this is still 2x squared. Now I've got 2 times 2 over 3. So that one is going to be 4. 2 times 2 is 4 over 3. The x squared times x will give us x cubed. And now I've got the next part, and that's where I've done, and I now know that I am correct. Right, now, remember here, we're not going to be given marks for the final answer. Okay, no marks for the final answer. Why? It is because we know the answer is already there, so we're not going to get marks for that answer. Okay, right. Because we know you do a lot of wrong things in there, and then from there you just say, therefore, v is equals to that. So we know we're not going to give you marks for the final answer. It's already there. So make sure that whatever you do there goes to what is given. Right, now, the next activity, activity 5, I'm going to do A only, and then you're going to do B and C. Right. TNML is a trapezium with TN parallel to LM. Oh, nice. It's a trapezium. Okay, so now it is in meters there. The measurements there are in meters. Show that the area, that is the area of the trapezium is, you see the answer again is given, 15 minus 3 into 3x squared. I'm looking at this question and say, but 15, oh, okay. But the fact of the matter, you must know the area of the trapezium. What is the formula for the area of the trapezium? First of all, the area of that is half. Done it in grade 9, grade 10 also, must know it. It's half the sum of the parallel lines. I'm just going to write this, parallel lines multiplied by the height. So in other words, it's the sum of 2x minus 3 and 4x plus 3, and we're multiplying it with this height. So I'm going to have half of, then the sum means that I'm going to add 2x minus 3 plus 4x plus 3 and multiply this by 5 minus x. Good. Now I'm going to have 1 over 2. What is inside the bracket? Let me add. It's 2x plus 4x, which will give me 6x. And minus 3 plus 3 will give me a 0. So therefore, I'm only left with this. Okay. Now I can see what is half of 6, which will be 3x multiplied by 5 minus x. So I've only done that part, first part. Now, the 3x multiplied by 5 will give me 15x. So that was supposed to be 15x, not 15. Okay, so it is 15x minus 3x multiplied by x will give me 3x squared. So that is 15x, not that. Okay, right. So now we have 15x minus 3x squared, which is the area of that trapezium. So we've got the area of the trapezium, 15x minus 3x squared. Okay, right. Now, B. It says calculate the value of x if TNML has a maximum area. So you see that maximum area. I'm going to write down the area because this is the one that you're going to do now. So it's 15x minus 3x squared. So it's B. You're going to do it. I'm only giving you 2 minutes to complete that question. Welcome back. Please, our WhatsApp number is 079-578-2908. Please send your answers to that number, 079-578-2908. Now, that question there, A equals to 15x minus 3x squared, it's our area. So we need to find the maximum area, the value of x, for which will give us the maximum area. That should be easy. We're going to find the A over the x. It's equals to 15 minus 6x. Then from there, we equate this to 0. Remember, always equate to 0 with the maximum. And then from there, minus 6x equals to negative 15. So x will be equals to 5 over 2. So that is our value of x. So that one was quite an easy one. So differentiation, and then from there you get to the final answer. Okay. Calculate now. This question we'll do it together now. Now it says calculate the maximum area of TNML. Let's connect it to the graphs. If I connect it to the graph that I've done, when we say calculate the maximum, remember you got the value of x, of which the trapezium will be at its maximum, will have a maximum area. So to calculate the maximum area, what does that mean to us? It means we need to find, when we connect it to the graphs, it means that we need to find the y value. So we already have the x value of the turning point. We need the y value of the turning point. In this case, when we say calculate the maximum area, we want you to find the y value of the turning point. In this case, how do you get it? You take the x that you got. Remember, the x we got 5 over 2 meters. So what do we need? We need to substitute it into the original equation. Remember, to get a y value of the turning point, you substitute it into the original. So I'm going to say then, my original is A, it's 15 x minus 3x squared. I need to substitute this into the original. So I'm going to have, because I need the maximum area. So it's 15, open bracket, 5 over 2, close bracket, minus 3 into 5 over 2, close bracket, squared. If I use my calculator in there, so I'm going to get 18,75. Remember, it's meters, it's area, so it's meters squared, square meters. Right. Okay. I think we're doing very well here. Okay. The last activity on optimization. Remember, we still have to do a calculus of motion. The last question on optimization. Very nice question here. Now we talk about the cylinder. Now, it says a container consists of a right cylindrical part and a hemispherical part at the top. So in other words, we have a hemisphere there on the top. As part of that, as shown in the picture and the diagram below, the radius of both the shapes is x. So we have the radius as x. Right. Remember this part here, it's part of the cylinder. Right. Okay. Now, the total height of the container, so the total height from the top there to the bottom is 66 minus 2x. You're given the formula, I like it when I'm given the formula. Write down in terms of x the height, this is 1 mark. Write down the height of the cylindrical part. So in other words, we need the height from here to there. Okay, so here, we know this is the radius, meaning that from here to there will also be our radius. So this is also x. So this part must not be there. I don't need this part. I only need this part. But I have that. Oh, I've already given you the answer. So meaning that I'm going to say the height of the cylinder, the cylindrical part will be 66 minus 2x. But because I don't need this part here, which is x in this way, then I'm going to subtract the x. So in other words, I'll have 66 minus 3x. So that is my height in centimeters. That's why it's 1 mark. Okay. Right. The next question here is, show that the volume of the total, the formula for the total volume of the container is given by that. You see another part where the answer is given. Most of the time in these question papers, we find that the answers have been given to you. So you just work towards the answer. Okay. I see I've got a 66. So already I know how, in my formula, I mean in my sum there I've got a 66. Okay. Now I've been given two formula. Remember the part that is on top. Let me go back. The part that is on top there, that part there, it's a hemisphere. Okay. It is not a sphere. Here, the formula that is given, it's a formula for a sphere. So for me to get the formula for the hemisphere, so hemisphere means half of a sphere. So you see why they gave you that formula. They did not give you the formula for the hemisphere, they only give you the formula for the sphere. So for you, you must then get the formula for the hemisphere, so which is half of it. Right. So I'm now going to say, now the formula for a hemisphere, the volume of a hemisphere, is going to be half of what was given. So remember, I'm given 4 over 3 pi r cubed. Meaning that the formula for that is going to be 2 over 3 pi r cubed. Check those formulas that are given and check what is given there. So what is given is a hemisphere. So I need the formula for the hemisphere. Now to get the total volume, I need the formula I need to add the formula, the volume of the hemisphere plus the volume of the cylindrical part. Then I'm going to get the total volume. Okay, so I'm going to get the total volume. Now, for me to get the total volume, then, what is the volume of a hemisphere? So it's going to be 2 over 3 pi. My r, I know it's going to be x, so it's going to be cubed. Now I know the formula there. Plus, what is the volume of the cylinder? So the volume of the cylinder, remember, is going to be pi squared, area of the base multiplied by the height. But I know that my height there, my radius there, it's going to be x. So that should be x there. So it's x squared. Okay. My height, I know what my height is. Remember, I've got the height of that, which is going to be 66 minus, because is the total volume, so it will be 66 minus the 3x, because it's the total. I need the whole thing. Okay. Now, in this case, yes, it's 3x. Remember, I need only the cylinder, okay? Only the cylinder, the sphere is already there. So now, how am I going to multiply this out? So I'm going to have 2 over 3 pi x cubed plus. Now remember, I've got an x squared here, so I'm going to multiply it inside the brackets. So I'm going to have 66 pi x squared. Then I'm multiplying the pi x squared with the 3x squared. I'm going to have, with the 3x, I'm going to have negative 3 pi x cubed. Nice. Now I can see I have common factor this and that. These two are common. Pi x cubed, pi x cubed. Then I'm going to start with my 66. I'll have 66 pi x squared, which I already have here. Nice. Then if I add 2 over 3 and I add it to minus 3, so my answer there is going to be negative 7 over 3. Then I can just put that one as negative 7 over 3 x cubed. Sorry, there's a pi x cubed. Therefore, that part is also correct. So now, when I have the answer, I must work towards the answer. Okay. All right. C says, hence, it means that use what you got there to calculate the value of x. That will maximize. When you see the word maximize, see, then, and I want you to go and practice this, go to your question papers and check. You see the word maximize, this is what it means. The total volume of the container. So now, it means that we're going to take that volume that we got, which was 66 pi x squared minus 7 over 3 pi x cubed. Then we're going to find the derivative of that. You see, I'm using different ways of finding the derivative there. Okay, so when you derive, we're going to equate to 0. So if I multiply 66 by 2, I'm going to get 132. Remember, pi will remain, and now we subtract the 1 there. If I multiply the 3 with 7 over 3, I'm going to get a 7. The pi remain, and we have got x squared. Then the whole thing there is going to be equated to 0. So I've got 7 pi x squared equals to 0. Then I take out common factor. So my common factor there will be pi x. So it will be pi x. Inside there, I'll have 132. Then from there, I'm going to have minus 7x. It's equals to 0. So to get the value of x, if I say pi x equals to 0, it means that x will be 0. Or I'll have x will be equals to, so if I take 132 to the other side, then from there divide it by 7, then the answer that I'm going to get there is 18,86. So that is centimeters. Okay, so I'm going to discard this. What is the reason? I cannot maximize with x equals to 0, because if I substitute by 0 here in my original, then there's no volume. You see? Okay, so my correct answer will be that one. All right. Then D says, hence calculate the maximum total volume of the container, meaning that we're going to substitute the answer that we got into the original one. So I'm going to say the volume will be equals to, so remember we've got 66 pi. If I substitute, I'm going to substitute by 18,86. There's a square there, minus 7 over 3. Remember, we've got a pi, and we substitute by 18,86, and there's a cube. If I use my calculator in there, remember we're not differentiating here, we're just getting the answer to this. So if I use my calculator, I get 24,576.74 cubic centimeter. Remember to put your units. Okay. All right. I think with optimization, now you understand that here we're just maximizing. Sometimes we minimize, sometimes we maximize. Please make sure that you understand this. The next part of work is the rates of change and calculus of motion. What I did there was just some little notes there to say distance. See, most of the time when they put distance, they put S. It's equals to f of t, or they can put f of t there, where S is the distance, t represent time, mostly in seconds, right? Remember, time, it's always going to be greater or equals to 0. So if you get a t which is less than 0, discard that answer. Okay. Speed, velocity, and we have acceleration. Remember, speed, the velocity will be the differentiation of the distance that we're going to be talking about here now. Okay, so it's going to be ds over the t. But when you come to acceleration, then that becomes the dv over the t. So in other words, you are deriving the v that we got there. So we get acceleration. Okay. Activity number 1. This is an easier activity, very easy. The first one, it says, when I throw the ball upwards so that it's height above the ground after time t, it's h. So you see you're given the height of the ball and the formula for the height. Okay, so it's measured in meters, and they say time is measured in seconds. So now we want to determine the equation that represents the velocity of the ball. The equation that represents the velocity of the ball. So in other words, what we are going to do, we're going to derive. So to derive, remember, we are now talking about the velocity, and here's the height, which is the distance. So in other words, therefore, we're going to say h, I'm going to say h of t, I'm deriving now, I'm going to get 20 minus 10t. That's all that we're going to do, because now we just need the equation, remember, that represents that. Okay. Right. Now, number 2 says, determine the time taken by the ball. Now, we need time now taken by the ball. Remember, that is the formula that we are using here. So we need the time taken by the ball to reach its maximum height. So now we need the time. To reach its maximum height means we are now going to take the derivative. We're going to take the derivative that we got, which was 20 minus 5t. 10t, the derivative. 10t, it's equals to 0. We need the maximum height. We derive. This is what when we derive, we get 20 minus 10t. So we're now going to get time. So how do I get time? So I'm going to say t is equals to 2. So it means that after 2 seconds, the ball will have reached its maximum height. Okay, so it's still the same thing as what we've done in the graphs to say we now have to find the value of t, and the other question can be what is the maximum height? Obviously, then I substitute this into the original equation to get that maximum height. But that question is not asked here. The next one is a bit of a challenge. I think the max there was supposed to be 5, cannot be 3. Now it says determine the velocity of the ball when it reaches 15 meters high on its way downwards. Nice question. So we know the height, it's 20t minus 5t squared. But we need the time, the velocity of that ball when it reaches 15 meter high. So it means I need to take this and put 15 first here, so that then I'll have an equation 5t squared. So I'm now going to write this equation properly and divide everything there by 5. So I'm going to have t squared minus 4t plus 3 equals to 0. In other words, I've already arranged it and divided everything there by 5. So for me now, I'm going to get time here. So I'm going to say t and t, it's 3 and 1. And I think that's minus and minus, if I'm not mistaken. T, it's 3, or t, it's 1. Now, I've got two answers there for t. So now how am I going to get the velocity of this? Remember, the ball will be 15 meter, will be 15 meter high at t is equals to 1. So if I substitute t by 1, it will be at 15 meter high, right? So now you can check that by substituting there. So if I substitute the value of t, I'm going to get 15 there. But now, what happens when I substitute t by 3? So if I take t, it's equals to 3 seconds. Then my velocity, do you still remember the formula for velocity? It was 20 minus 10t. That was the formula for velocity. Remember, we differentiated height, and then we got it there. So now, my velocity here, it's going to be negative 10. If I substitute this one by 3, I'm going to get negative 10 meters per second. But then what does that mean? It means that when the velocity is negative, it means that it's going downwards. At the height, it was at 1, and it's going downwards now. The t, after 3 seconds, then it's going downwards. At 1 second, it was at 15, and at 3 seconds, it was going downwards because it was negative 10. Right. Bit of a challenge there. Right. Now, activity 2. So that is why that one, the activity that I've done there, I said it's about 5 marks there. So you can see there's some work to be done. So you need to understand what you're doing there. Okay. Activity 2, that's an easier one. A tourist travels in a car over a mountainous pass during this trip. The height above the sea level after t minutes. Now we're talking minutes now. Remember, t is type, so it can be minutes, it can be seconds, it can be hours. The journey, the S is given there. The journey lasts 8 minutes. Now they say, how high is the car above the sea level? So remember, now I'm talking how high, distance, how high. So in other words, I'm not going to be differentiating anything because I know you love differentiation. When you see something like this, you just want to differentiate. Read the question first. Right, so it says how high, meaning that my S, my T is going to be 0 there. How high? Above the, when it starts the journey, remember, when it starts, so it will be at 0, time will be at 0. Right, so T will be 0. So when you substitute 0 there, 0 there, 0 there, then we are only going to get 100. So it will be 100 meters. How high? So it's 1 Mach. So just substituting the value there by there. 2 says calculate the rate of change. See, that word now mean derive. The rate of change. So what are we going to do there? We are going to derive the rate of change of the height with respect to time and 4 minutes after starting. So we want to find the rate of change. So 4 minutes after starting. So what are we going to do? We are going to derive. When we derive, we get 15t squared. We get minus 130t plus 200. I'm going to quickly go back. Right, so I'm going to get 3 times 5, it's 15. 2 times 65, it's 130. 1 times 200 is 200. The differentiation of a constant is 0. All right. Now, we have that. So, but they say the rate of change 4 minutes after starting. So, meaning that my t there must be equals to what? 4. So, I'm just substituting t by 4. So, I'm going to say 15 into 4 squared minus 130 into 4 plus 200. And when I put this in my calculator, the answer that I get there is negative 80. So remember, this is negative 80 meters per minute. Remember, here we're talking minutes. We're no longer talking seconds here. Right. So now it's minus 80 meters per minute. So that's the rate of change. Remember, it's like your velocity. So in this case, it's rate of change. Okay. Now, the question that follows this says, now interpret your answer in B. Our answer in B, it says minus 80 meters per second. Okay. Do you remember the negative 10 that we got meters per second? Same applies to this one. How do we interpret this? We'll say the height of the car above the sea level is now doing what? Is it increasing or decreasing? It is decreasing. So in other words, this person is going down. So the rate of change there, it is decreasing. The velocity is decreasing. It's going down. So decreasing by what? By 80 meters per minute. So each and every minute is decreasing by 80 meters. Okay. But the next question says, how many minutes after the journey has started will the rate of change, you see, when they talk rate of change above the sea level will be a minimum. Will be a minimum. So, meaning that, what are we going to do there? We are only going to derive. So once we derive, we are going to find time because we're talking about how many minutes. So the derivation that we got was 15t squared minus 130t plus 200. And then we're going to take this and equate it to 0. Oh, sorry, before we equate it to 0, remember what we got here, it's velocity. It's velocity, yes. So now, but they say the rate of change of height above the sea level. So now, how many minutes after the journey has started? So what should we do there? We need to derive the velocity. So how do I derive the velocity? So if I derive velocity, I'm going to get v of t, which is going to be 30t minus 130. Okay, so I'm equating that to 0. I'm equating that to 0, then to get the value of t. So my t, 30t will be equals to 130, and then t will be equals to 4,33 minutes. Please don't confuse that velocity with, because now it's accelerating. Okay, so then we have to differentiate the velocity. Okay, so in how many minutes, after how many minutes, then we need the t. So the t there will be 4.33 minutes. Okay. All right. Now I am tempted to give you activity number 3. Yes, activity number 3, we still have some time. Activity number 3, please, I want you to do this activity number 3 in 2 minutes. I think in 2 minutes, you'll be done. Okay, welcome back. I hope you have done that question. Now it says during an experiment, learners must record the velocity. Now it means that the velocity has been given. They record the velocity of the toy car, which is there, velocity. The first question says determine the initial velocity. So once you say initial, then we know we need the velocity v at 0. So if I put a 0 there, I'll get 8 meters per second. So because this will be 0, that will be 0, so I'll get 8 meters per second. It's only one mark, so no problem there. Right. The second one says determine the velocity of the toy car when t is 0.2 seconds. So it still means I'm still looking for the velocity, and the formula that was given was velocity. So it means that I need a velocity at 0.2 seconds. So I'm substituting my value of t by 0.2. That one is 0.2 all squared. Then I'm going to have, if I put it on my calculator there, my answer becomes 8.76 meters per second. So you see, it's not very far from the first question, which is 8, because with 8, we have a 0. At 0.2, it has moved 8.76 meters per second. Now, the last question says rate. When you check this, at which rate, determine the rate at which the velocity changes with respect to time. Remember when we derive, we say we're deriving this with respect to. So it means that we're deriving here. So when I derive v, I'm going to get, v of t, I'm going to get 4 minus 2t. That one was an easy exercise. Now I need this at 1.2 seconds. So in other words, I'm going to have 4 into 1.2. I substitute into the derivative. So the answer that I'm going to get there is 2.56 meters per second squared in this case, because it's acceleration. Okay. All right. Now, the last question that we're going to do now is this one. Now we're saying a cuboidal tank is full of water. So if it's full of water, then they say a tap is opened and the height of the water level H is given by that equation, where T is the number of minutes. Now we're also talking minutes here. So the units are very important. And they say determine the height of the water level when the tap is open. That is when the tap is open. What will be the height of the water at that particular time? So meaning that our H, our T will be 0. So I'm having H of 0. So if I substitute that by 0 and that by 0 and that by 0, what is my answer? 48 meters. I'm talking the height now. Okay, so the height will be 48 meters. Now, the second question says, determine the height of the water level 2 minutes after the tap is open. The height of the water 2 minutes after the tap is open. So it means I'm still talking about the height. So meaning that I'm only substituting the value of T by 2. So if I substitute by 2, so I'll get 2 cubed minus 2 squared minus 16 times 2 plus 48. Then if I use my calculator, I'll get 16 centimeters. Right. So you can see that now I'm talking about the height. So the height after the tap has been opened, 2 minutes after the tap has been opened, the height will now be 16. It was 48 at the beginning. Now it has dropped to 16 because the tap has been opened and we are counting in 2 minutes. Right. C says, determine the rate at which the height of the water level. You see the word rate? Then I know because I'm doing rate of change there. So I'm going to now differentiate. So to differentiate, and after differentiating, I need to find the value of my differentiation in 2 minutes. So when I differentiate this, I'm going to get 3 over 2t squared minus 2t minus 16. But they say after 2 minutes. So meaning that my derivative there must substitute that by 2. So I'm going to get 2 squared minus 2 into 2 negative 16, of which then if I work it out, I'm going to get negative 14 centimeters per minute. All right. Okay. The next one there talks to determine how long will it take. Now I need time. I need t. How long will it take? How long it took the height of the water level to drop to a rate of 8.5. So in other words, the rate, so it means that I'm talking derivative. So that one is derived. So the h of the derivative was 3 over 2t squared minus 2t minus 16. But we're talking about how long will the water level drop to 8.5. So here I'm going to put negative 8.5. And then I'll have 3 over 2t. So remember here I'm talking about the rate of the drop at 8.5, negative 8.5. Now with that equation, I can just simplify that. When I simplify that, the simplification of that will lead me to 3t squared minus 4t minus 15, it's equals to 0. So if I work that one out, 2 times that, and then from there, I then transpose everything to my right-hand side, then this is what I'm going to have. That's my equation. For this, I'm going to factorize to get, remember we need time, so I'm going to have 3t plus 5, I'm going to have t minus 3. So I'm going to have t, it's equals to minus 5 over 3, or t, it's equals to 3. What did we say about time? This one is not going to be applicable because you cannot have a negative 5 over 3 seconds. Okay. So that is what we're going to do on that question. So my correct answer there will be t equals to 3. If I substitute t by 3, then I get minus 8.5. Right. The last question, you can take that for your homework. So I can just give you 1 minute to take that question and go and do it as a homework. Thank you so much for attending this lesson and have a great day going forward. Thank you.